You know the technology that renders those incredible lifelike graphics in your favorite video games? Well, what if I told you that same exact tech is also helping cure diseases, predict climate change, and is the absolute bedrock of the AI that's reshaping our entire world? It all comes down to one piece of hardware, the graphics processing unit, or GPU. Today, we're taking a deep dive into this incredible acceleration engine. Okay, so to really get why GPUs are such a game changer, you've got to understand their more famous cousin, the CPU. Think of a CPU like a master craftsman, a brilliant chef who follows a super complex recipe, step by step, with incredible precision. Now picture the GPU. It's not a single chef. It's a gigantic assembly line with thousands of workers. Each worker is just doing one simple, repetitive task. But, and this is the key, they're all doing it at the exact same time. That is parallel processing, and that is the GPU's superpower.
So, how has this assembly line approach actually changed anything? Well, for starters, it's pretty much single handedly ignited the artificial intelligence revolution. Modern AI, especially deep learning, is built on a foundation of doing massive parallel calculations, a job that GPUs seem like they were literally designed for.
Let's look at how an AI model actually learns. First, you feed it a mind-boggling amount of data. But the real heavy lifting, that happens during what's called iterative training. This involves millions, sometimes billions of repetitive calculations. It's like showing a model a picture and asking, is this a cat? Over and over and over again. A CPU would have to ask that question one by one, but a GPU, it asks thousands of those questions simultaneously. This speeds up the whole process so dramatically that the model finally gets it, and that's what we call convergence.
And this incredible speed up gives us this amazing win-win-win situation. I mean, it's not just about getting the answer faster. When you reach that convergence point sooner, the models use way less power, which is a huge deal for energy efficiency. And because researchers can run so many more experiments in the same amount of time, the final AI models often end up being way more accurate and powerful. Of course, all this amazing hardware power would be kind of useless if developers couldn't actually access it easily. That's where these absolutely crucial software frameworks come into play. You've probably heard of them, things like TensorFlow and PyTorch. Think of them as universal translators. They let AI researchers write their code, and then the framework automatically translates it to tap into the massive parallel power of the GPU. It's brilliant, really. Now, beyond artificial intelligence, this paradigm of parallel processing is having a profound impact on fundamental science. It is providing researchers with the computational tools to address problems of immense complexity, problems that, until very recently, were considered intractable. A key domain of application is material science. As detailed in recent literature, GPUs are utilized to accelerate the complex algorithms required to simulate nanostructures. This capability allows scientists to effectively model the behavior of materials at the atomic level, which is a critical precursor to designing novel medicines, higher efficiency batteries, and next-generation electronics. The performance gains realized here are not merely incremental. For certain computationally intensive problems, such as solving large linear systems, GPU acceleration offers speedups of 1,000 times or more when compared to traditional CPU-based methods. This does not represent a simple improvement. It is a fundamental phase shift in scientific capability. This computational power also finds significant application in environmental science, particularly within the complex domain of global climate modeling. A predictive understanding of our planet's climate necessitates the simulation of an extraordinarily intricate system of atmospheric and oceanic interactions. This excerpt from a 2023 study effectively captures the primary benefit. The term more granular refers to higher resolution. GPUs enable scientists to model the globe in much smaller, more detailed segments. This, in turn, allows for more realistic physics within the simulation and, consequently, improves the predictive accuracy of our climate models. Okay, so we've seen AI, and we've seen some seriously heavy science. But believe it or not, the impact of this technology doesn't stop there. It's now rippling out into some truly surprising fields, creating whole new capabilities that just weren't possible a few years ago. Get this, quantum computing. Now, true quantum computers are still a little ways off, but we can use the GPUs we have right now to simulate them. It's this really cool hybrid approach where researchers can develop and test quantum algorithms today. It's like building a flight simulator for a jet that hasn't even been invented yet, and it's massively accelerating progress in the field. And how about the world of finance? In high-frequency trading, decisions aren't made in minutes or seconds, they're made in microseconds.
That same parallel processing power that trains an AI is used here to chomp through these enormous streams of market data in real time. It allows algorithms to make trades faster than any human ever could, and it's fundamentally changed the very speed of the market itself.
This progress is absolutely incredible, but let's be real, it's not automatic. Unlocking the full potential of this technology means we have to tackle a whole new set of challenges and start looking toward what's next in computing. So, what does that road ahead actually look like? Well, first, there's a big focus on the software. You could have the most powerful GPU in the world, but you need really cleverly optimized code to squeeze every last drop of performance out of it. Second, the hardware itself has to keep evolving. As AI models get bigger and bigger, we need new, scalable architectures to handle that load. And finally, researchers are getting creative, exploring these hybrid approaches, combining GPUs with other next-gen tech to see what new doors they can unlock.
Which really brings us to a final and pretty powerful question. This technology, GPU acceleration, has given us a tool to solve problems that we once thought were literally impossible. We've unlocked a new scale of computation. So the question isn't really about what the technology can do anymore. The real question is, what should we do with it?